Hello, dear participants. Today we will learn about inferential statistics, hypothesis testing, ANOVA, and confidence interval. When we talk about inferential statistics, we try to make predictions from the data. You have a sample and you try to make some generalizations about a population. As we have discussed in previous videos, having the data of complete population is time and cost consuming. So we generally work on sample data. In inferential statistics, we try to create reasonable estimates from a sample. It is a process of using data obtained from a sample to make estimates and test hypotheses about the character of the population. We have point estimate and interval estimate. In point estimate, I'm having a single value. For example, sample mean is the point estimate of the population mean. Whereas in interval estimate, I am having the range of value where the parameter is expected to lie. When we talk about the hypothesis, hypothesis can be defined as the statements or assumptions or claims which can be verified. It is of two types, null hypothesis and alternate hypothesis. In null hypothesis, we take no effect, no impact, no relationship between variables. Whereas in alternate or research hypothesis, we take presence of some effect, some impact, some relationship between variables. In alternate, we have the predictions from a theory. We always test null but want alternate to be true and null to be rejected. We denote them by symbols. Null hypothesis is generally denoted as HO and alternate hypothesis is generally denoted as HA. You can verify the symbols as per your requirements. These are generally used symbols. So in my further video, you will be seeing symbols HO denoting null hypothesis and HA denoting alternate hypothesis. Some examples of hypothesis. For example, you want to check the relationship between stock returns and macro variables. So your null hypothesis will be there is no significant relationship between stock returns and macro variable. Whereas your alternate hypothesis will be there is a significant relationship between stock returns and macro variables. Let's take another example. Now you want to check the impact of poverty on the living standards. So your null hypothesis will be there is no significant impact of poverty on the living standards, whereas your alternate hypothesis will be there is a significant impact of poverty on the living standards. If you want to compare the drug trials on the patients during the COVID time, we have heard like drug A, drug B, drug C, drug D have been tested on the patients. Now, suppose you want to just compare two drug trials on the patients. So, your null hypothesis will be there is no significant difference between drug A and drug B on patients. Your alternate hypothesis will be there is a significant difference between drug A and drug B. Let's take one more example. If you want to check the relationship between lockdown and family bonding. During the lockdown period, we all were staying at home and you just want to check how much it is impacting, or is there any relationship between lockdown and family bonding. So your alternate hypothesis will be there is no significant impact of lockdown on the family bonding, whereas your alternate hypothesis will be there is a significant impact of lockdown on the family bonding. Similarly, if you want to check the impact of COVID-19 on the Indian economy, your null hypothesis will be there is no significant impact of COVID-19 on Indian economy, whereas your alternate hypothesis will be there is a significant impact of COVID-19 on the Indian economy. To test the null hypothesis, we use sample information to obtain the test statistics. Mostly, this test statistics turns out to be the points estimator of the unknown population parameter. We can use either confidence interval approach or test of significance approach. Test of significance approach, we are having the p-values. In p-values, it can be defined as the lowest significance level at which the null hypothesis can be rejected. If my p-value is less than given level of significance, null hypothesis is rejected. What is my level of significance? The level of significance is the probability of rejecting the null hypothesis when it is true. For example, level of significance at 5% indicates 5% risk of concluding that a difference exists when there is no actual difference. It is also known as alpha. If your p-value is more than your level of significance, null hypothesis cannot be rejected, or you are not having enough evidence to reject the null hypothesis. You can also say you have a very little statistical evidence or support for your research hypothesis. But if your p-value is less than your level of significance, null hypothesis can be rejected, or you have enough evidence to reject the null hypothesis. You can also say you're having strong statistical evidence to support your research hypothesis. Generally, we take level of significance at 5%, but depending upon your research, literature review, and other parameters, you can also use level of significance at 1% or 10% or a combination of all three. Some terminologies we never use. If your p-value is more than your level of significance, you can never say accept null hypothesis, reject alternate hypothesis, or null hypothesis is true, alternate hypothesis is false. You are not going to use this terminology. Similarly, if your p-value is less than your level of significance, you will not use the terminologies like accept alternate hypothesis, null hypothesis is false, or alternate hypothesis is true. Now I'm moving towards the ANOVA. In ANOVA, we compare means of more than two populations. For example, the mean cholesterol content of various diet foods, the average mileage of 5 automobiles, to study the difference among the various type of drugs for curing the COVID-19, the average telephone bills of households of 4 different income groups. Here we have the total variation and we break it into two parts. In the first part, I will be talking about the specific causes of variations between samples. And in the second part, I will be talking about the chance variation of within variation. For example, chairs. If there are five manufacturers of chairs, so the difference may be due to the method they are applying, the raw materials they are having, and the process they are using. Also, there might be inbuilt variations due to the size, quality of the chair. In ANOVA, we study any number of factors which are supposed to influence the dependent variable of interest. The dependent variable is metric, which means either of interval scale or ratio scale, whereas independent variable is categorical, means nominal scale. In one-way ANOVA or single factor ANOVA, there is one independent variable divided into various categories, whereas in two-way ANOVA or two-factor ANOVA, we have two factors each divided into various categories. Some assumptions we make while applying the ANOVA. Each of the samples is drawn from a normal population. Each population has a equal variance. All the factors except the one being tested are controlled, which means all the factors have been held constant. These are the formulas we use in ANOVA, but thanks to the softwares, our life is easy. Let's take up the questions. Suppose you want to compare the cholesterol contents of the four competing diet foods on the basis of the following data in milligrams per package, which were randomly taken 6-ounce packages of each of the diet foods. You want to check whether difference among the sample means can be attributed to chance at 5% significance level. You have the data with you. So, what will be your null hypothesis? Your null hypothesis will be mean of diet food A is equals to mean of diet food B equals to mean of diet food C equals to mean of diet food D. Your alternate hypothesis will be at least two means are not equal. I'm moving to my Excel workbook now. Here I'm having the data. For this, I need to have the data analysis pack with me in the data tab. This is my data analysis tool pack. How can I have that? Simply, I can insert file, more, options, add-ins, go. Simply take analysis tool pack, press OK. You will be having this data analysis tool pack here. It is already pre-installed in my system. Open this data analysis tool pack. You can see ANOVA single factor. Press OK. Input range. Select your input range. Simply put your cursor and drag it out. Yes, I'm having the labels in my first row. I will be having alpha at 5%. Press OK. As I'm having my results on a new sheet. So a table has been generated. You can see the p-value. What is my level of significance? 0.05. What is my p-value? Here is my p-value. As I can see, my p-value is greater than my level of significance. Hence, null hypothesis cannot be rejected. You can say I'm not having enough evidence to reject my null hypothesis. I've simply copy pasted the data here, and this will be my result. Similarly, if you want to check the speed of typewriters, you have 3 typewriters with you. What will be your null hypothesis? Mean of typewriter A is equals to mean of typewriter B equals to mean of typewriter C. And your alternate hypothesis will be at least 2 means are not equal. Moving to my Excel workbook again. I have this data. Go to my data tab, data analysis, ANOVA single factor, okay. I will select my range, labels in the first row, alpha, new worksheet, okay. Now, my level of significance is 0.05. My p-value is equals to this 0.08513. Now, my p-value is less than my level of significance. Hence, null hypothesis my p-value is this. Now, my p-value is less than level of significance. Hence, null hypothesis can be rejected. Or you can say, I'm having enough evidence to reject my null hypothesis. Clear? Similarly, if you want to check the average mileage of 3 different cars, or you want to check the difference of ratings of restaurants, you can apply single factor ANOVA. Let's practice more questions. Suppose you have 3 methods like method 1, 2, and 3. You have the result. Although your data is not balanced, still you can apply single factor ANOVA. Data analysis, single factor, okay. I'm having the range, labels, alpha, okay. Again, my p-value is less than my level of significance. Hence, my null hypothesis can be rejected. Similarly, I'm doing for the ratings I have of 4 different restaurants. Although my data is not balanced, how can I go by? Data analysis, ANOVA single factor, okay. I will select my range, labels in the first row, alpha, new worksheet, okay. Again, my p-value is less than my level of significance. Hence, null hypothesis can be rejected. So this is my one way ANOVA or single factor ANOVA.